Alright, so I did designing a bicycle material for Trek, and yeah, here's my presentation. So first, a little bit about me. Um, I won 2 Nobel Prizes. Of course, I am knighted, have an IQ of 3,000, and I am a materials expert, of course. Um, so for the Trek bike, we focused on the budget bike, and basically what Trek wanted out of the budget bike was it had to be light, it had to be durable, very inexpensive, and also it had to be able to be mass produced. So those are the confinements, as one would say. We looked at a bunch of different groupings of materials, and we placed them into metals, polymers, woods and fibers, and ceramics, the 4 categories. And we evaluated them on 4 different characteristics: the hardness, tensile strength, elasticity, and melting point. Um, the metals were hard, and they were very strong tensile strength. They were very elastic, and they had high melting points. Um, the polymers, the polymers were very soft. They had a very strong tensile strength. They were very elastic, and they had a low melting point. The woods and fibers we did not we did not measure the hardness. They had a very weak tensile strength. They were very inelastic, and we could also not measure the melting point. And the ceramics were very hard, very strong, pretty elastic, and also very high melting points. We also evaluated the specific materials. We chose 2 materials categories: metals and ceramics, that we thought would be best suited for the bike frame. We evaluated them on 2 different categories that we thought would be important in making a bicycle frame: oxidation, which is basically like, does it rust, and then density, how heavy it is. So we found that ceramics don't oxidize, and metals do oxidize. Ceramics, their density is about 2.6 to 6.0 grams per centimeter cubed, and metals can be anywhere from about 1.5 to 22.6 grams per centimeter cubed. And so you might think that, oh, ceramics are the hardest, just plainly from the numbers, are the hardest, the strongest, they would be best, right? We actually chose aluminum for several reasons. It's light, it's durable, but it's also inexpensive. So many ceramics can be very expensive, and also many ceramics are very hard to work with, so they're very hard to mass produce. Whereas aluminum is really easy to machine and make into a bike frame, especially with the tubing and stuff. And also, aluminum is also very durable. We actually chose aluminum 6061, which is aluminum alloy. It's aluminum mixed with a little bit of usually silicon and magnesium and a little bit of other things, but the main other 2 metals of the alloy are silicon and magnesium. Alright, and a little bit about the alloy and how the molecules and the molecular arrangement of aluminum looks. There's this thing called the sea of electrons effect, and basically what that does is all of the metal atoms, instead of each one of the metal atoms having specific electrons that apply only to that atom, there's actually all of the electrons apply to all of the atoms, kind of like they share their electrons. And so what that gives is that makes it a lot stronger and has a lot higher tensile strength. So like one atom is connected, instead of just like one atom being connected to one other atom like a bond, one atom is connected to all of the other atoms, so it's like a really strong bond between each individual atom and the whole group of metals, if that makes sense. And it's just really hard to rip apart. And there's also, you can see here the visual of an alloy. It's kind of like, if you imagine the blue is aluminum, and the red is the magnesium and silicon and copper and all the other things. There are about 8 different ingredients in aluminum 6061. But imagine that the reds are other things. They're kind of just in there. They're just put around. They kind of just stay. They're not in a specific orientation um, concerning with respect to the aluminum atoms. And that's what it looks like, and that's my presentation. Thanks for watching.